This section is talking about counting atoms, and we started this a little bit. We introduced the atomic number to you and the mass number on the periodic table. The atomic number is symbolized with a Z, and it is the number of protons of each atom of an element. So the atomic number is the number of protons. The number of protons changes with the element. So if you change the number of protons, you change what element you're looking at. Now, isotopes are atoms of the same element that have different mass numbers. Now, this mass number is made up of the protons and the neutrons, as you can see right here. Total number of protons and neutrons make up the nucleus of an isotope, and that is the mass number. So, when we are looking at different isotopes, there's examples. There's carbon-12, if you've heard of carbon-12, carbon-14, carbon-12 dating, carbon-14 dating. There's hydrogen-1, there's hydrogen-2, and hydrogen-3. Those are all isotopes. They have different mass numbers. So if you can get from this that these are standing for mass numbers, these numbers here are standing for mass numbers. And you can see it either has a mass number of 12 or 14. And for hydrogen, it's 1, 2, or 3. And there's other isotopes of carbon, but those are the main two. Uranium, probably that's a real common one for everybody, is there's a 235 uranium, and I'm going to write this out here. So uranium-235. And then there's also uranium-238. One is radioactive and one is not. One is not very common and one is more common. So those are different isotopes. They have a little bit different properties, but overall they have the same properties. Mass number is the total number of protons and neutrons. So we have that. But then the average atomic mass compared to mass number. Mass number is going to be a whole number because you're counting particles. So you have protons and neutrons. We have a certain number of people in our classroom, boys and girls. When we add those together, we get the whole class, the number in the whole class. So if you think of the mass number, you know, like protons being boys, neutrons being girls, you're always going to come up with a whole number of the number of students in your class. You're never going to have a decimal. There isn't 12.1 people in our classroom. So the mass number is always going to be a whole number. The average atomic mass, however, it could be a whole number, but more than likely it's going to have decimals. It's going to be a fraction of a number because it's weighted. So depending on how many you have of each isotope, that's how many you would put into the equation to solve. And we'll do some of these equations in class tomorrow to help you know how to do that. Hyphen notation. So how do we identify or how do we label isotopes? Well, earlier I did the hyphen notation, which is just simply there's a hyphen, then the mass number. So hydrogen 3, hydrogen 1, hydrogen 2, that's the hyphen symbol or hyphen notation. The nuclear symbol is written in a different format, and I'm going to draw it and hopefully it'll stay on. Okay, I wasn't able to get it to draw on there, but I did find an isotope symbol. Now, the element symbol would go in this position, and then the mass number goes up here, and the atomic number goes down here. So A stands for mass number, and that's the number of protons plus neutrons, and Z would be your atomic number. So if we did this for hydrogen, let's do it for hydrogen 2 right here. You would have an H where this X is. You would have a 2 where this A is. And then if you look on the periodic table, the atomic number for hydrogen is 1. So you would have a 1 down here. So that's how those are written. A nuclide, however, is another name for isotopes. So if you have an isotope, a specific isotope, say you have uranium-235, you would have the nuclide uranium-235. So you have a certain nuclide or an isotope of uranium. Now, the atomic mass unit. The unified atomic mass unit has been determined based on carbon-12. carbon-12 being an isotope of carbon with a mass number of 12. We set one atomic mass unit as exactly 1/12 the mass of a carbon-12 atom. And they didn't just come up with this number. There is a beautiful mathematical reasoning behind this. But for your purposes, 1/12 of the mass of carbon is one atomic mass unit. So hydrogen has an atomic mass of 1, and it is 1/12 the mass of carbon. Magnesium has a mass number of 24, so it is 2 times the mass of carbon-12. So that's how it's set, and that's where they come from. And then when we get the averages, this is where we found isotopes. We've massed all those isotopes, and then we've calculated the average atomic mass. We will do these calculating average atomic mass together in class tomorrow. So that's part of what we can do in class tomorrow with you getting the information in there tonight. So the mole is a new term, I'm sure, for you. The mole is an amount of a substance that contains as many particles as there are atoms in exactly 12 grams of carbon-12. So when we take 1/12 of carbon-12, we get 1 atomic mass unit. So carbon-12 is 12 atomic mass units, and they took those 12 grams and they counted those out, not exactly, but they have an idea of how many particles are in this 12 grams of carbon-12, and they call that a mole. So if I have 12 grams of carbon, I have a mole of that substance. It is like saying if I have 12 of something, we call that a dozen. So if I have 1 mole of something, we have what we call Avogadro's number of that particle. And that would be 6.022 times 10 to the 23rd. That's a very large number. Okay, that's a very large number. And so we have 12 equals a dozen, and we have 6.022 times 10 to the 23rd equaling a mole. You can't even count to this number in your lifetime. That's how large this number is. So Avogadro is obviously the guy who came up with this number, mathematically came up with this number based on carbon-12. 12 grams of carbon has this many particles in it. So what a tedious job to sit there and count the number of particles in 12 grams. It's not what he did. And we'll work on this in class as well. But that is a number you have to memorize, or I would write that on your note card right there. 1 mole is equal to 6.022 times 10 to the 23rd, and that's particles. It could be anything. Just like a dozen can be anything, right? We have a dozen, let's try to get this all in one line. You have a dozen eggs, you have a dozen people, you have a dozen bags, you have a dozen pencils, anything. A dozen always means 12. So whenever you hear a mole, if I have a mole of people, a mole of atoms, a mole of molecules, I always have 6.022 times 10 to the 23rd of them. Okay? Now, when you take the mass of 1 mole of a substance, that's called its molar mass. So molar mass, or mole, or mass of 1 mole, right? So that's where you see this mole and molar coming from, but it's the mass of 1 mole, mass of 1 mole. That is going to be some calculations that we're going to do in class as well. So on page 80, there's going to be some examples, and then we'll do all of these sample problems in class. So now we have lots of class time to work on lots of example problems and do our homework together in class. That is it for this section. This section seems like short for terms and notes, but when we do the problems, that's going to take some time and some thinking. So remember to bring your calculators to class tomorrow. And your periodic tables, you're going to need them. Okay, Thank you. Have a good day. And don't forget to do the lesson assignment.